In this short segment, we're going to see how to delete a node from a doubly linked list. So up to now, we've built the doubly linked list from two classes, node and Sentinel DLL. We've seen how to do insert, and we've seen how to do append, which is just rewiring a couple of connections. So let's see how we delete something now. All right, so we're going to write a member function of Sentinel DLL. I've got my doubly linked list here, circularity, Sentinel, doubly linked list. And I want to delete X. So I give you the node that you want to delete. And what does it mean to delete? Well, all it means is that node pops out, and that means this guy's next is no longer X, but it's what X was pointing to. And this guy's previous is no longer X, it's what X was pointing to in the previous line. So that's conceptually what we want to do. And it should be relatively straightforward. It really just seems like we have to change one connection this way and one connection this way, and then that node just flies away. All right, so let's see what this looks like. So my delete is going to have 2 lines of code. We have to follow through this a little bit, so let's see what happens. So X is the node I want to delete. So what do I want to do? I want to take my previous node, and I want to say, you're next. I'm looking down to my left. Your next is my next. Whoop, right? I do this. So X, follow it, dot previous, dot next, that's that arrow right there, is equal to X dot next. So when I evaluate this, I literally will take this guy's next, and I will run it over me and point it to whom I point to. And what happens is now this guy's next is this node here skipping over me. And then I want to do the same thing in the other direction. X dot next dot previous, so that's this link right here, is no longer X, but it should be who I point to in the reverse direction, which of course is just X.previous. So I reach in here and I grab the link and I go like this. And what happens at this point is, if we follow the yellow links, it's next, next, and then previous and previous. So I'm still sort of hooked in there, but nobody knows about me. I've like free-falled myself. It's as if I've taken the safety cables, done this, and now I'm no longer effectively in the list, because if you follow from the Sentinel through and you follow the arrows, I am gone, right? There is no connectivity there. Now, that data structure, that node, still exists. That's an interesting problem of where does that get cleaned up. But from the point of the view of the list, it may as well not exist. And what invariably happens is something called garbage collection, which we will not talk about in this class, which says that data that is not being used effectively can be freed up. But that is not your problem. You don't have to worry about it. The only thing you have to worry about is that the list no longer points to that object. And so there's something a little perverse about the way you've done this. You've gone to this object, to this node, and you've basically said, I'm going to extricate myself from this list by rewiring everybody around me, and then I can just take a step back and I no longer exist. So notice that the delete, the insert, and the append all rely on simply manipulating these connections, because those connections are what define the list. What defines a linked list is follow the next and now follow the previous's, and if I can manipulate those, I can add things and delete things and move things very easily. Okay, so that's it for this short segment. When we come back, we're going to do a little bit more on doubly linked lists before we do the runtime complexity.